Hi, in this video I'd like to talk to you about our unit circle and how we can use the unit circle to help us easily remember trig function values for some of our common angles. For this video we'll be sticking with degree measurement angles, but the same exact thing applies for radian measurement. You just add in the corresponding radian measurements that correspond to the degree angle you're looking at. So what we're going to need to recall in this video though is our special right triangles. And so let's remind ourselves of those. That if I've got a, let's see, a 30, 60, 90 right triangle, what we are guaranteed is the relationship between the three side lengths is going to be that we would usually call A the side opposite 30. Then A times radical 3 would be the side opposite the 60-degree angle, and the hypotenuse is guaranteed to be 2A. Now this is always going to be true. You can verify it with the Pythagorean theorem. If you were to take A squared and A root 3 squared and cleaned it all up, you would indeed get 2A squared. Okay, so this is our special 30, 60, 90 triangle. We have another special right triangle, and that was the 45, 45, 90. And my picture, my first triangle there is really not drawn to scale. They both look like 45 degree angles, but never trust a picture in math, right? Always trust the labeling. Anyways, with a 45, 45, 90, it's an isosceles triangle, so the side opposite one of the 45s, if we call it A, then it's the same side is also A because it's also opposite a 45-degree angle. And what's going to be guaranteed to happen is that the hypotenuse is going to be A times radical 2. And again, you can verify with the Pythagorean theorem that that's going to be the case always for a 45, 45, 90 triangle. The two legs will be the same, and the hypotenuse will be radical 2 times the length of one of those legs. Okay, so how can we use this with a unit circle? You may have seen in other videos how I can use these special right triangles along with SOHCAHTOA to help me find sine or cosine of a common angle. For example, if we recall SOHCAHTOA, and let's say that I am trying to find sine of 30 degrees. Well, I can use this diagram I already have built here with my special right triangle. Sine is opposite over hypotenuse, right? And so the side opposite sine, 30 degrees is A, and the hypotenuse is 2A. The A's would cancel, and this would reduce to 1/2. Sine of 30 is 1/2. And we use these common angles so much that they are worth memorizing. You want to know what sine of 30 and sine of 60 and cosine of 30 and 60 and 45 are. We don't take the time to memorize anything else. Like we would never take the time to memorize sine of 20 or cosine of 50 because those do not correspond to special right triangles like we have here. But these guys are very common to use, and so we will save a lot of time if we can commit them to memory. Now, memorizing things is very challenging for many folks, myself included. The unit circle is a fantastic way to memorize and be able to figure out all the trig function values for these common angles around the entire circle. Okay, so for all these common angles between 0 and 360 degrees. So let's begin our picture, and you've seen in other videos how we measure our angles. So an angle in standard position, if you recall, is drawn with the initial side on the positive x-axis, and we rotate counterclockwise to represent some positive angle. Okay, and so I just want to stick right now with 30-degree angles. Let's just worry about that. So let's take a look at a 30-degree angle drawn in quadrant 1 here. This is 30 degrees. And I would really like to know what is the sine and cosine values for this angle. Okay. All right. Well, let's figure them out. Because it's a special right triangle, and I know this little angle here is 30 degrees, don't I know that I can call this side A, and I'm looking at this right triangle that I've constructed here. I can call that side A. That means this little guy up here is 60, right? Since they all have to add up to 180, which makes this side a times radical 3 according to my special right triangles, and the hypotenuse is guaranteed to be 2a. Now, the way we label sine and cosine on the unit circle here is as an ordered pair. So I'm going to write the ordered pair, and the thing to remember is that in those ordered pairs we always write the cosine value first, cosine of your angle and then sine of your angle. Okay? Oh, you can't see what I just wrote there. What I was doing is I was telling you that we always write our ordered pairs with cosine first and then sine. So let's find cosine of this 30-degree angle. Cosine of 30 degrees is supposed to be adjacent over hypotenuse, right? Cosine is adjacent over hypotenuse. So let's figure that out. Adjacent to 30 would be a radical 3 over the hypotenuse of that triangle, which is 2a. The a's are going to cancel and you get radical 3 over 2. That's the cosine of 30 degrees. And sine of 30 degrees we actually did right up here, right? So I've already got that. That sine is 1/2. Now you might be thinking, how the heck is this going to help me remember this? Well, it's going to. Just hang in there. Before I go to like the 45 or 60 degree angles, let's finish off the 30 degree angles around the circle here. So where else would I have a 30 degree, what I would call a reference angle? Basically an angle that is 30 degrees off the x-axis. Well, let's see if I can clean some of this up. This angle also would have the same cosine and sine values, because if you take a look at it, it forms a 30-degree angle with the x-axis, or a 30, 60, 90 right triangle with the x-axis. And because this angle is 30 degrees right here, that's referred to the reference angle. I mean, the whole purple angle itself is actually 150 degrees, we've learned from another video. Right? Remember, all the way around halfway around the circle is 180 degrees. So if you go to 180 and then peel back 30, you're at 150. Okay. And so this is 150 degrees out here, but I want to find the sine and cosine values for that angle. I'm going to do this for every angle who has a reference angle of 30 degrees. The reference angle is one of your best tools in trigonometry. So this has a reference angle of 30 degrees, again, because it's 30 degrees from the x-axis. If I draw a triangle incorporating the axes, it creates a 30, 60, 90 triangle. All right. Well, let's take a look at that triangle we just drew. Opposite the 30 we know is A. I mean, that makes this little guy up here 60. Opposite the 60-degree angle should be a radical 3. Now, careful. If I'm traveling this distance, I'm going left. Shouldn't that be a negative distance? So it is a distance of a radical 3, but it should be negative since I'm going to the left. Now, the hypotenuse is always positive. It's 2a. Let's find cosine and sine of these values. Remember, I'm going to write my ordered pairs. I'm going to write the cosine of that angle of 150 and then sine of that angle of 150. Well, cosine of 150, I know it's confusing because you're thinking like, well, I'm looking out here and that's not a triangle. It turns out the sine and cosine for this angle here is the same as it is for its reference angle, okay? You just have to make sure your signs are correct. All right, so cosine is adjacent over hypotenuse. So standing at this 30-degree reference angle, adjacent is negative a root 3. Hypotenuse is 2a. The a's cancel and I get negative root 3 over 2. Let's look at sine of 150. Again, 150 degrees will have the same sine and cosine as its reference angle does. They might be off by a plus or minus sign, but they're not how we're doing it. We incorporated the correct minus sign here in our diagram, but there's other ways to think about the problem. Anyway, sine asks for the side opposite your angle divided by the hypotenuse. So this would be positive a over 2a. This would be 1/2 after the a's cancel. Okay. Now, oops, that erased. In the beginning, it takes some time to build and develop the unit circle, but I promise you it's going to become your best friend, and it's going to really accelerate your ability to find these trig function values. Now, let's jump to the shortcut here. Let's look at the cool part about the unit circle here. Let me move my work. What do you notice about these angles? The red angle 30 degrees and the purple angle or blue angle I've drawn here at 150 degrees. Do you notice that they have the same cosine, except it's off by a minus sign, and they have the same sine? And that's true for any angle who has a 30-degree reference angle. If I draw an angle with a 30-degree reference angle to it, meaning it's 30 degrees off the x-axis, either above or below, I know what cosine and sine are going to be. So for example, let's take a look at this angle here. If I want to draw this angle that goes all the way around here, what would that be? If it's got a 30-degree reference angle here, I'm saying that angle is 30 degrees, then this would be 180 and 30 more. That makes this 210. Well, I can repeat what I've done. I mean, I can say, well, I know I've got a 30, 60, 90 right triangle there. I can label the sides accordingly and use SOHCAHTOA to find cosine and sine. Or if I recognize that I'm going to just begin to do the same steps over again, I could say, well, I know that the cosine is going to be root 3 over 2, and the sine is going to be 1/2, guaranteed. Now, I'm not sure if I got the plus or minus signs right. So if you were to work it out by hand, we would say, okay, well, this is going to be, the side opposite the 30 would be a negative a, since I'm going down. And again, since I went left, this should be negative a root 3. And the hypotenuse is 2a. I can do that, but there's a faster way to remember these signs. Okay, there's a better way to do it, and that is to remember that all students take calculus. All students take calculus. What that's doing is that is telling me which trig functions are positive in that particular quadrant. Everybody else is negative. In quadrant 1, all trig functions are positive, and we see that here, right? They came out positive. In quadrant 2, only the sine is positive, which means by default the cosine is negative. In quadrant 3, only the tangent would be positive, which means the cosine and sine must be negative. Now let's quickly do this next one. What would be the angle in quadrant 4 who has a 30-degree reference angle? That would be 330 degrees to be 30 degrees off the x-axis. All students take calculus. Well, because I've got a 30-degree reference angle, I know my cosine and sine. It's root 3 over 2, and it's 1/2. Guaranteed. Now in quadrant 4, cosine should be positive, so this guy needs to be positive, which means by default then, everybody else, including this sine, must be negative. And so you can see that by just knowing one of these values, particularly if you know quadrant 1, you really know all the other quadrants worth of 30-degree reference angles. You know their sine and cosine. Now this same exact procedure can happen for your other common angles, right? Let me try and clean this up a little bit before the video ends. But imagine you've got, so there's my 30-degree angle, imagine you've got a 45-degree angle. You can calculate out what the cosine and sine are. Spoiler alert, you're going to get rad 2 over 2 for both of those. Okay. Now,